Hello all, myself Suma R, working as Assistant Professor in Department of ECE, MIT, Mysore. So today we will be discussing about the Boolean algebra and logic circuits. So under this, let us take the first topic, binary numbers. So first let us understand what is a number system, then we will move on to the binary numbers. What is a number system? A number system is one which is used to represent the information in quantitative format, right? So now if you consider number system, that too in computer language we have 4 number systems. In this we have decimal number system, then we have binary number system, next we have octal number system, then at last we have hexadecimal number system. So these are the 4 number system we usually use in digital logic or in digital language. Yes. Now if you consider the binary number system, so let us understand how to represent the number in binary number system by considering decimal number system first, because decimal number system is the one which is we are very familiar with. Therefore, so let us consider number in decimal. Later we will arrive at general representation for any number system for that matter. Yes, let us consider a number, say for example 8954. So we read it as, or we write in compact format. So if you write the expanded form of this number, so how do we write? So we write this in expanded form as 8954. So this is how so the expanded form of this compact number is represented. But usually we never represent any number in expanded form, we usually go for compact form. So this is the compact form in decimal number system. Therefore, so if you observe, so here this can be written in another format as 8 into 10 to the power 3 plus 9 into 10 to the power 2 plus 5 into 10 power 1 plus 4 into 10 power 0. Yes. So if you observe carefully, so we have some coefficients here. So we are not using the powers of 10 to represent the number in the compact form. Instead, we are using only the coefficients to write or represent any number. Therefore, so in general, we can represent the number in terms of coefficients. Let me start from A5. Here we have only 4 digits. So I am starting, since we are writing in general, so I am taking some higher coefficients also. A5, A4, A3, A2, A1, A0. So if you consider this number, whatever I have written here, so here we have A0 as 4, A1 as 5, A2 as 9, A3 as 8. So I have considered 2 extra digits here. So if the number is in fraction format, then we write like this. So A minus 1 dot after the decimal point. So we write A minus 1, A minus 2, A minus 3, etc. This is how we can represent any given number using its compact, that is coefficient. Using the coefficients, we represent the number in compact format. So this is the representation of a given number in decimal number system. Now, so coming to the binary, so as I said, let us generalize, let us generalize and let us represent general equation for any number system. So how to represent a number in any number system. So later we will consider the binary. Now let us generalize and let us represent the equation for any number system. The generalized equation for representing any numbers in any number system. Let us consider the base radix as r. Okay, if that is the case, using these coefficients we can represent the general equation like this. So a5 into r to the power 5 plus a4 into r to the power 4 plus a3 into r power 3 plus a2 into r power 2 plus a1 into r power 1 plus a0 into r power 0 plus, so we need to represent, okay, the numbers after the decimal point. So they are represented like this: a minus 1 into r power minus 1 plus a minus 2 into r power minus 2, a minus 3 into r power minus 3, etc. Now, okay, so this is the general format for representing any number, okay, in terms of its coefficient. So if, for example, if I consider this number, so I have already written the representation of this. Now let me consider, okay, the digits after decimal point also, okay, the fraction numbers. Now, so how it is represented? Let me change here itself, okay, here the expanded form. So I have represented 8 into 10 power 3 plus 9 into 10 power 2 plus 5 into 10 power 1 plus 4 into 10 power 0. How it will be continued? Plus, okay, you can observe that, plus. So we need to write the next coefficient a minus 1 into 10 power minus 1. So r power minus 1 we have written. So here, since the base is 10 for the decimal number system, radix or base is 10. Therefore, so we need to, okay, multiply the coefficients by, okay, the weighted powers of the radix. So here we have 7 into 10 power minus 1. Next will be a minus 2. A minus 2 is 5. Okay. Then, so will be multiplied by 10 power minus 2. So this is how we represent, okay, or we write the expanded form using the general equation. Fine? Yes. Now we need to discuss binary numbers, because the topic what we have taken is binary numbers. So now let us move on to the binary number system. So binary number system is a special number system, because we have only two values there. So one is 0, the other one is 1. Only two values are there. Therefore, using those two itself we need to express all the numbers whatever we use, we need to represent using only 0 and 1. So now the coefficients what we have here, a0, a1, etc., all this will be either 1 or 0. Okay, so that is the point which we need to keep in mind. And the radix will or base is 2, because it is binary, we have only two values, so base will be 2. So here we need to multiply those coefficients by 2 powers depending on the position of those. Okay, we need to multiply respective coefficients by respective, okay, 2 powers. Yes. Now let us consider, okay, we will consider this octal number system, hexadecimal number system later. So now let us continue with the binary number system. As an example, I will consider a binary string. Yes. So let me consider 101101 dot 0 double. Okay, let us consider this binary number. So let us see how to represent this in the expanded format, okay, using this generalized equation. Yes. So here if you count the digits, number of digits, we have 0, 1, 2, 3, 4, 5. So highest power of 2 will be 5. Therefore, let us start 1 into 2 power 5 plus 0 into 2 power 4 plus 1 into 2 power 3 plus 1 into 2 power 2 plus 0 into 2 power 1 plus 1 into 2 power 0 plus, yes, next we need to, okay, consider the digits what we have after decimal point. So we have 0, 1, 1. So 0 must be multiplied by 2 power minus 1. Then 1 must be multiplied by 2 power minus 2. And again the last digit 1 must be multiplied by 2 power minus 3. Yes. Now let us find out the equivalent value. So when we find the equivalent value, remember, so we are going to get the decimal equivalent of it. Even if you consider the octal or hexadecimal number also, so even in that case, if you write the number in expanded form, using this general representation, then the equivalent value will be the decimal value, decimal equivalent of the given number. Yes. Now it is in binary. Whatever the answer we are going to get will be in decimal. Let us find out. So we have 1 into 2 power 5. 2 power 5 is 32. 2 power 5 is 32. 32. Next we have 0 into something. Yes, 0 into anything is 0. And next we have 1 into 2 power 3, which is 8. Plus next we have 1 into 2 power 2. 1 into 2 power 2 is 4. Next we have 0. Yes. Next we have 1 into 2 power 0, which is 1. Plus next we have 0 into 2 power minus 1. Plus next we have 1 into 2 power minus 2. 1 into 2 power minus 2 is 1 by 4. 1 by 4 is 0.25. Plus 1 into 2 power minus 3. 1 into 2 power minus 3 is 1 by 8. So 1 by 8. So its equivalent is we will get around 0.13. So 0.13. If you want, you can consider one more digit. Now let us find out its equivalent. Yes, we have 32 plus 8. 32 plus 8 is Yes, now let us find out its equivalent. So we have 32, again we have 8, so 32 plus 8 is 40, 40 plus 4, 44, 45, so 45, because we have lesser number here, so I am doing addition from this side. So we need to add, first the fractional values. So if you get carry, we need to consider that also. Yes, here, so we have 0.25 and here we have 0.13. So 0.25, 0.13. So what is the equivalent? So we have 38. So 45.38. So this is the decimal equivalent of the binary sequence, whatever I have considered. So this is about the binary number. Now let us see the representation of numbers in all the 4 number systems. Yes. Now, as I said, if I consider decimal number system, so how many digits we have in decimal number system? 10, right? Then we need to consider binary. Let us write the binary, equivalent for this decimal number system later. So next we need to consider octal. Next we need to consider hexadecimal. Now in this representation, let me consider, since I have hexadecimal number system, in hexadecimal we will be having digits from 0 to F, 16 digits will be there. Therefore, so I will be writing all the 16 digits for that, and again, so equivalent to that whatever the representation we have in octal, that is I am going to write 16 numbers. So in octal number system, even in binary as well as in decimal number system. So let me start from here. Since I have hexadecimal, I will be writing up to 16, even though the number of digits here we have is only 10, that is from 0 to 9. So I will be writing up to 16 because I have hexadecimal in which we have 16 digits. Yes, so 0, 1, 2, 3, 4, 6, 7, 8, 9, 10, 11, 12, continuation. So I will be writing here 13, 14, 15. Since I have started from 0, so I will be ending at 15. So though we have 16 digits there. Okay, for hexadecimal we will be having 16 digits. Yes, so I have written the equivalent of hexadecimal number in decimal number now. Let me write the same 16 numbers in binary. So in order to represent 16 or in order to represent 15, actually not 16, since we are starting from 0, here also we will be having the maximum value, that is the last value as 15. Therefore here 4 bits are sufficient since we can represent the 15 using 4 bits. So I am representing or writing equivalent of these numbers in binary using 4 digits. Okay, yes. So I have 0 0 0 0 here. Next 0 0 0 1 0 0 1 0 0 0 1 1 4. Next 5 6 7 8 9 10 11. Okay, so I have up to 12 here. So after 9, so I will be writing 1 0 1 0 10, okay, 11 12. Fine. So how to write the binary numbers? So you should know how to write the binary numbers for any given decimal number or octal or whatever. Okay, so how it will be done? So for any given decimal number you need to understand, when you are using 4 bits, just understand the positional weights of this. So we have 8421, we call 8421 code sometimes. Using these values, so you need to represent these digits. Say for example, if you are writing 9, so 9 is nothing but 8 plus 1, by adding which of the digits, which of the numbers or which of the positional values you get the equivalent decimal number, you need to see, and then accordingly you need to write. Say for example, if you are writing 12, 12 can be represented by as a sum of 8 plus 4, 8 plus 4. So we don't require 2 or 1, right? So you need to write 1 in place of 8, 1 in place of 4 and 0 in place of 2, and 1 again 0 should be written in place of 1. Yes. So now if you observe 12, as I said, so so how writing 9, then you need to add 8 and 1. So if you add 8 and 1, we know that, so we can get 9. Therefore you need to write 1 in place of 8. Then you need to write 0 in place of 4. Why? Because I don't require 4. 8 and 1 are sufficient to get 9. Therefore, so you need to write 1 in place of 8, 0 in place of 4, next 0 again in place of 2, and at last 1, because 8 plus 1 will contribute or will result in 9. So this is how we write the binary equivalent for a given decimal number. Yes. So I have written up to 12. Let me continue here. So binary representation 13, 13 is 8 plus 3, 8, plus 3, 2 plus 1. So 3, next 14, 14 is 12 plus 2, 12 is 1, 1, 8 plus 4 plus 2 plus 0. 15 is 8 plus 4 plus 2 plus 1. So this is how we need to write the binary equivalent for any given decimal number. Now let me write the octal number. So octal, how many digits will be there in octal? So we will be having 0 to 7. In binary only 0 and 1. In decimal, so we will be having 0 to 9. Whereas in hexadecimal 0 to F. Yes, octal. So now we have the maximum value what we have is 7. So we need to be careful while writing the number. So in octal representation, how do we write? We write 0 for this, 1, 2, 3, 4, 5, 6, 7. Up to 7 you need not have to worry. You need to just write as we write in case of the decimal number system. But 8. So what is the representation, or how do we write a number after 9? How do we write? We write the number as 1 0, that is 10, right? So similarly here also after 7 we need to write 1 0, that is 8. In octal, since we have maximum number as 7, so after this next number will be starting with 1 0, similar to the decimal. 9 after 9, how do we write? So similar to that, so we need to write here also. Therefore, so next number is 1 0, which is nothing but 8, okay, in decimal number system. You can check that. So how do we check? So if you write the expanded form of that number, you will be getting equivalent of that in the decimal. Say for example, we have 1 0, so 1 into 8 power 1 plus 0 into 8 power 0. Yes, 1 into 8 is 8 plus 0 into anything is 0, so 8. Therefore, 1 0 in octal will give you 8 in binary, 8 in decimal number. Okay, let us continue. Therefore, after 1 0, 8, this is 9, this is 10, okay, 11, we need to write up to 12, right? Yes, let me, okay, 8, 9, 10, 11, 12, okay, next 13, 14, 15, 13, 14, 15. So we can answer. Yes, now let us write hexadecimal numbers. So we have 16 digits, so we need not have to worry here. But again, so here up to 9 we have so we have digits same as, okay, the decimal number, but after that what we need to do here is, so we have symbols for representing the number. So we will not be writing, okay, 10, we will be writing A, capital A instead of 10. So A, B, C, up to 12 we need to write, yes, 12 is, this is 9, 10, 11, 12, okay, yes, A, B, C. And how do we represent 13? D, 14? E, 15? F. So these are the different, okay, the representations, different number systems what we use in the logic circuit or digital, okay. So in the digital design, these are the different number systems we use. So I hope you have understood. So how to write the numbers in binary, how to write the numbers in octal, and how to write the numbers in hexadecimal. Okay. So this is about the binary numbers. Okay. And in the next class, we will be learning about the number conversion. Okay. Thank you.